Okay, so we'll go to part 2 of this class that talks about what? Factors. We have talked about prime numbers. And the reason I dealt with factors first was to be able to pass the reason I talked about primes first was to pass the message of factors better. Now, we come to factors. Just as we said under prime numbers, every number existing on Earth has at least 2 factors. Every number existing on planet Earth has at least 2 factors, itself and 1. I will simplify that on the board. So if I write any number, with the exception of 1, because we had established earlier that 1 has only 1 factor. So this one is the only number that has 1 factor. And we don't, and if you look at, maybe you'll have asked, we didn't talk about 0 because 0 is not a factor. Why 0 is a number, it is not a factor. We can't divide things by 0. It causes a lot of problems. So I just want you to remember that there's a reason why we will not be using 0. You get it? All right. Okay, so that settles that. 0 not being considered as a factor. All right, 1 is a number, both a number and a factor. All right, so let's look at that. 1 is both a number and a factor. It has 1 factor, which is 1. 2 is also a number, a prime number. It's a prime number. Is a number. Remember, for it to be a prime number, it must first of all satisfy the condition of being what? A number. And not just any number, a natural number. Take note that the numbers we are talking about at this level are essentially natural numbers. What are natural numbers? Whole numbers that are positive. All right. So, and it's also what? A factor. And in this case, it has what? 2 factors. So we've said that all numbers have at least 2 factors. All numbers have at least what? Apart from 1, every other number has at least what? 2 factors. Good. So 1 is a special case. Now, we come to, let's say, 4. What are the factors I can get from 4? I can get 1, I can get 2, and I can get 4. So we're going to be using 2 major techniques to get out factors here. That's what they call the factor tree method, and there's what we call the LCM approach. I call it the LCM approach. So we're going to use both and see how that plays out. Now, let's look at exercise 3A of your textbook. Our official text, once again, for this class is the New General Mathematics for Js1, grade 7. I will be looking at page 15, exercise 3A. Question 1. Find all the factors of the following numbers. I'll just pick a few of them. I'll start with 1A. Exercise 3A. Question 1A. It says what? Find all the factors. Find all the factors of the given numbers. So A, look at A. Look at A, it says what? 12. Now, there's something we call the factor tree. Now, if you look at this, let's start with a very simple approach to help us grow. Okay, so let's look at looking for the factors in 12. Now, we can say that 12 is what? 12 times 1. 12 can also be what? 6 times, or let's flip it the other way, 1 times 12. And this one can also be what? 2 times 6. And we can also have that 12 is equal to what? 3 times 4. I seen that. Now, we can also say 12 is what? 4 times 3. We will not need this one anymore because we've gotten all the possibilities. If I'm using numbers that I've used before, it means that I'm repeating them unnecessarily. So I'm clean this. So what would be the factors? Now look at it. I look for unique numbers. I can see 1, I can see 2, I can see 3, I can see 4, I can see 6, I can see 12. So the factors will be what? 1, 2, 3, 4, 6, 12. Now, these are things you do gradually. You must do them gradually. You do them gradually. Now, I can also use another method to do this. Now, method you use is a function of how vast you are in the topic. Now, I can use another method. I could say 12. I can break 12 to become 2 and 6. I can break 6 to become what? 2 and 3. Now, so the factors, if I'm using this method, how does this method work? Now, if I'm going to use this method, look at what will happen. The only reason 12 will exist is because 12 is multiplied by 1. So then I look out for unique factors again. I look out for unique factors. I'm saying 2, I'm saying 3, I'm saying 6. And remember that we said that every number has a factor of it. It's a factor of itself. So I write 12. But look at it. I have 4 here. How come I'm not seeing 4 here? Look at this thing very well. 4 has occurred how many times? 2 times. So 2 times 2 will be what? 2 has occurred 2 times. 2 times 2 will be what? 4. So it means that there's a 4 here. I will not write them in that order. 1, 2, 3, 4, 6, and 12. So this is one method. Depending on your level of your understanding, this is one method. This is another method. Now, let's use another method. There's the method, another method we use. We write 12 here. Now, we call this the prime column. That is, the numbers that can divide this must be prime numbers. So, because this is an even number, we start by using what? 2. 2 divide 12 will give me 6. This is also an even number. So another prime factor I can use will be what? 2. Notice that now I'm using prime factor. A factor is what can divide a number. Do you get it? So a factor is what can divide a number. Now, I'll get 3 here. I can see 3. I can divide this with 3, and I'll get 1. So if I'm using this method, how do I list the factors? Remember, the only reason this 12 is existing is because it is multiplied by 1. So I'll put 1. I'm saying 2. I put 2. I'm saying 3. I put 3. I'm saying 6. I put 6. The next thing I do, I check. I'm seeing 2 occurring twice. I put what? 2 times 2 will be what? 4. Remember that every number is a factor of itself. So 12 will be there. After that, I rearrange. 1, 2, 3, 4, 6, and 12. So what will be our task? I'm giving you 3 methods. So you're going to use the 3 methods to solve exercise 3A question 1. Use all 3 methods. All 3 methods to solve question 1. A to J. This is A to J. Solve all the questions. Because remember, this is the heartbeat of arithmetic. The more you solve, the more you begin to see. Now, all these methods are important because in solving problems, there are problems that this will be easier, this will be better than this. And there are problems that this method will be better than this. So you need to know these 3 methods and know at what point in time can I use whichever one. Some people may love this method better than this, better than this. All right, so we're going to solve 1 or 2 more questions. And after that, I'll leave you to go back to work. All right, so we're going to solve these 3 questions now, but I'm going to use only one method to solve each one. So this one, I'll use my method 1, which will be 18 1 times 18, 2 times 9. Remember, after 2, what's the next number? 3. So you work with the concept of 1 and prime numbers times 6. Now the next one will be what? 6 times 3. So that means I don't need to do any more. So the factors will simply be 1, 2, 3. Permitted to write under 6, 9, and 18. So I've done that one. Now let me use another approach here. I'll use my tree diagram here. I'll put 20 here. 2 times 10, 2 times 5. Now, so how does this work now? My factors here. I'll start because there will always be 1. There will always be 1. I'm saying 2. Is 2 occurring more than once? Yes. So 2 times 2 will be what? 4. After that, 5. After 5, 10. And after that, 20. That will be the factors I will have. I go to method 3. I'll solve 2, 12, 2, 6, 2, 3, 3, 1. What will be the factors? 1 must always be there. Next, 2. I'm saying 2 occurring twice. That will be 4. I'm saying 6. I'm saying 3. Okay, let's go with the other approach to make it faster. Let me write all the numbers I'm saying. I'm saying 2. I'm saying 3. I'm saying 6. I'm saying 12. And I'm saying 24. You must always end with a number you're given. So what's the next thing you do? I check. 2 times 2 is 4. 2 times 2 times 2. You must exhaust all the specific prime factors you're seeing. 2 times 2, I have an option 4. 2 times 2 times 2, I have an option 8. Then the next thing is to rearrange them. I'll have 1, 2, 3, 4, 6, 8, 12, and 24. So those are the factors you're going to have. All right, so that takes care of that. And then we're done with that one.